Hello. For my exploration topic, I chose to research the area of airspace interference, especially related to EMI filtering in modern aviation. First of all, let's learn what EMI is. EMI, standing for electromagnetic interference, is on a basic level any unwanted electromagnetic input that a circuit may pick up. As airspaces are becoming more crowded with various EM wavelengths, EMI is becoming increasingly concerning, especially in modern aviation, which is developing a dependence on its electrical systems. For instance, in flight controls, many aircraft utilize fly-by-wire systems, in that the controls are no longer mechanically connected to the control surfaces, but rather control input is received and the plane's system acts on that. The plane's radio communication and sensitive flight instrumentation can also be affected by EMI. Some sources of EMI for aircraft can be external, such as lightning, radar, HIRF, which are high-intensity radiated fields, and also internal, from the aircraft itself across the different systems, or originating from certain personal electronics. There are several ways to combat EMI in aircraft, such as material considerations and resonance, to correct grounding, that should be used in conjunction to minimize disruption. In regards to frequency-specific shielding, one facet engineers can include to decrease the impacts of EMI is including low-pass filters in the airplane circuitry. This simply means the circuit will only pass low frequencies, allowing input to mix with high-frequency interference without majorly affecting the output of the filtering aspect. These will utilize transformers and capacitors, inductors, as in the example RC and RL filter circuits we analyzed in this class, or a combination of all three. This involves analyzing the circuit to find the transfer function, which is the phasor output over the phasor input. This function can then be used to figure out how the circuit acts at high frequencies versus low frequencies, to then determine the type of filter it acts as. During this course, we learned to interpret transfer functions using Bode plots, such as the example image on the left, which shows the Bode plot of a low-pass filter. On the right, you can see a general circuit example for EMI applications in aircraft. While researching, I found a couple discussions I thought were interesting. One being from an article published by NASA, which told an anecdote of a pilot disengaging autopilot and immediately spinning dangerously to one side and dropping significantly in altitude, because the autopilot had been automatically compensating for EMI in its controls. Another interesting comparison is the impacts on military versus commercial planes, as commercial planes are inherently stably designed and military are not. So EMI is potentially a greater threat to military crafts. Thank you for watching, and I hope you have a great day.